second graders. We are here with our next hands-on science lesson of the day, and it is lesson 2. And can you figure out what page that is really quick for me?
Yeah, that is page 22.
Yes, so start by opening your science books to page 22, and we're going to be testing how flexible 4 of our items from our science kit are. And I think there is actually one item that's not in your science kit, which is a wooden ruler. If you have a wooden ruler at home, you can grab it. If not, you can just watch what we do with the wooden ruler, and it's no big deal. You can just use the other 3 things and just watch what we do with the wooden ruler. All right, so our challenge for today is we need to imagine that we need to tie something, like our shoestrings, right?
Oh, yeah.
We tie our shoes, except when I'm wearing boots.
Okay.
So if we need something to be able to tie it into a bow,
Yeah.
what properties would it need? What would it need to be?
String.
Okay, string is not a property, that's a material. A property describes is it hard, is it soft, is it flexible?
Okay. Well, I think we would need something a little bit soft.
Mm-hmm.
And yeah, we need it to be able to bend and move around each other.
We don't want something stiff and hard that can't bend,
No,
right?
yeah.
So we're going to predict which of the materials is the most flexible, which is another word for bendy.
Oh, kind of like my arms when
Like
when I
arms.
do this.
Yes.
I'm really flexible.
Exactly. So if it's a really flexible, really bendy material, usually we can tie it into some kind of, knot or bow.
Okay.
Okay, and then we're going to decide of those materials which is the least flexible. Just like last time we did the hardness, we had 4 and we put them on a scale of what was the hardest, what was softest. Today we're going to be testing those 4 items to see which is most flexible and which is the least flexible or least bendy. So Ms. Marquardt's going to show us what we need out of our science kit right now.
All right.
So first, a wooden ruler, which is not in your science kit, but if you have one, you can go get it. Next, a pipe cleaner, and it's just this long, white, kind of fuzzy feeling. Then we have a piece of spaghetti, 1 piece of dry spaghetti. And finally, we have a little piece, it looks really big on the screen, but if I can show you guys, the little piece of cardboard is this small. It's just a little rectangle piece of cardboard. It just looks really big because we blew it up on the screen. All right, so those are the 4 items that we're going to be testing today. And so before we test any of them, before you start bending anything, just by looking at them, we're gonna make a prediction as to which we think is the most flexible, most likely to be able to tie it into a knot, and which is the least flexible. So let's make our predictions. If your predictions are different, that's okay. Most flexible, I'm gonna say maybe the cardboard.
Okay.
I bet that's probably pretty bendy. All right, and again, you can have a different, prediction than I do. What do you think is gonna be the least flexible?
I think the ruler.
The ruler, okay.
Yeah.
So she's gonna write down the ruler. And now we're going to have to carry out an investigation and have a way to test those objects and see what happens when we apply force, which is a push or a pull, or in this case, we're going to try to bend those objects and see what happens. So, and the next step is the same as yesterday. You're gonna draw a picture of what the item looked like before you bent it, which is over here without force on the right. And then over here, you're going to draw a picture of what it looked like after you bent it with force, okay? So why don't we just start with the ruler?
Okay, well, you said that we have to apply that force. This time, I don't know if pushing on an object is really going to be helpful. So I'm thinking we kind of need to
try to bend it?
Yeah, somehow kind of bend it, because you said we have to tie it.
Yeah.
Or try to tie it into something. So which material, do you want to try one?
Yeah, I'll try the ruler. I mean, I don't want to break it and destroy your property, but it is not bending. You can see there's a little bend in it, but it is not moving very much.
No.
It's definitely not changing its shape at all. So if I were to use this for my picture, it would just be a straight ruler, both sides. It wouldn't change.
Probably the same each time.
And definitely I'm not going to be tying this anytime soon.
I don't think you're going to tie your shoes with that.
No.
Okay, how about the cardboard?
All right, what should we do? We're going to just try to bend it and see what happens. Oh, well, if you guys are trying this at home too, take your cardboard and bend it I can even put a crease in it, and it bends pretty easily.
That's cool.
Pretty bendy.
Yeah.
Huh.
Wow.
Yeah.
Okay. Well, we also have a pipe cleaner.
Oh, let's try that guy.
Ooh,
Oh, let's
I'm gonna
switch.
throw it on the ground.
Okay, thanks. Okay, when I take my pipe cleaner, and hopefully you guys have your pipe cleaner, I can bend this pretty well
Oh wow.
in lots of different directions, and
That's
it
beautiful.
can go in and out and around each other. It's very flexible.
That is very
It's
flexible.
very flexible.
I feel like my spaghetti noodle's gonna be pretty flexible too.
Let's try. What happens when you try to bend it in half?
Oh.
Oh my gosh, you just broke it.
Oh.
What happened when you bent yours in half? Did it break like ours did?
Wow. I didn't know that was going to happen.
And if you happen to have an already broken one because maybe your science kit got smashed or something, take a smaller piece and do it again. It still keeps breaking. It does not bend very well.
That is not very bendy.
Yeah. If you apply force to it, it's just gonna.
It broke. And
Yeah.
I mean, being flexible means being bendy without breaking.
Yeah.
Not just being bendy. Like I
Yeah.
could bend it, but I ended up breaking it.
Exactly.
All right.
So any of these objects, just make sure you draw a picture. So Miss Marquardt, do you want to draw maybe the spaghetti? Can you lift it
Yeah.
up so we can
I'm
see
gonna
what you're
draw. Well, I'm gonna start without force.
without force?
So that's just going to basically be like a super straight, skinny line.
okay.
And when I applied force, I don't know if they were watching carefully, but
Yeah, I created two.
I don't know if you saw on the ground.
There are some pieces
There
that flew around. Yeah,
a couple pieces.
quite a few pieces
on-
that broke off.
So yeah,
Oh,
that
nice.
is
I
what
like
happened.
Very good. Then you're going to have to explain what happened when you tested that material, that piece of spaghetti with force. When you bent it, what happened?
All right. Well, I think in our case, the spaghetti broke.
Yes, it definitely broke. And if you chose a different material to draw a picture of, just explain what happened. Maybe you had the ruler and nothing happened when you applied force because it was just very hard. Maybe you bent the cardboard and it was very flexible, but maybe you couldn't tie it. It was pretty flexible, but you just couldn't tie it. All right, so let's take a look at the next page. On the back, we are finally to the part where we are going to be putting these in order. What was the most flexible at the top, down to number 4, which is the least flexible. And again, just like yesterday, we're not going to write these down for you, so you need to make sure that you're listening so you get the right word in the right box. So let's talk about number 1, the most flexible item.
All right. Well, I think you have it in your hand.
Definitely the pipe cleaner. We
Yeah.
were able to bend it, it didn't break. We were able to, I could even tie it if I want. You can see that, I tied it. I could probably put a pretty bow in it. It might not be pretty, but yes.
You can
So-
do a lot with a pipe cleaner.
Yeah, you're definitely gonna write pipe cleaner for number 1. So that leaves us with cardboard, spaghetti, and ruler. What do you
Mhm.
think we should say is the next most flexible?
All right. Well, the cardboard, you were able to fold that and put a crease in it, and it didn't break.
Yeah,
But you could still bend it. So I think
Yes.
cardboard is definitely going to be number 2 on our list today.
I would agree with you.
Okay.
All right, so that leaves us with spaghetti and the ruler. And this is what's tricky because spaghetti was kind of flexible. We could, to a point, bend it,
Yes.
but then it broke.
it did.
The ruler wasn't really flexible at all.
No.
And we could have broken it if we applied enough force.
Mm-hmm.
But I would say that was probably the most rigid, the least flexible, right?
Yeah. Because the spaghetti bent a lot. If they watched that video, it kind of bent all the way until, it just couldn't go any
Yeah.
farther.
Definitely.
But the ruler, there's no way it would have been able to bend with that same curve that the spaghetti had
Yeah.
before it broke.
Yeah.
So,
So we would definitely write spaghetti on number 3 and ruler on number 4 for the least flexible. All right, so that's showing us that if I were going to need to tie something and those were the only 4 objects that I had, I'd probably go with my pipe cleaner as it has the property of being the most flexible. So before we do the very bottom reflect part of our page, we have a very quick video that we're going to show you guys, and then we'll answer the questions at the bottom, okay?
Can you spot the flexible materials? Rubber. Brick. Glass. Concrete. Paper. Wood. Rubber and paper are flexible materials. Brick, glass, concrete, and wood are not.
All right, so if you were paying attention, they definitely gave us the answer to that problem on the reflect part of our screen. It says the flexible materials in the video are rubber and paper. So go ahead and write those two down at the bottom in those blanks. Rubber and paper. Flexible, they bent. Awesome. And that is it for today's science lesson. Thank you guys for tuning in and doing your best.